Welcome to the flipped instructional session for Math 08A for Unit 612, Function Stories. Our objective for today is to describe the real-world relationship between two quantities depicted on a graph. We do have some vocabulary today. A constant function is a function that does not increase or decrease as x increases. So when we say as x increases, that means as we read something left to right. So as x is going left to right, nothing happens in the y. This is constant. A decreasing function decreases as we read it left to right. And then therefore increasing is a function that goes up as we read it left to right. So we'll need to know those as we move through this today. So for which values of x is the function linear? So this is a review just to make sure you remember that linear means a straight line. So A and B, these are straight lines, but it asks for which values of x. So here's for this value of x all the way, let's just do it in 2. Here to here, which is -7 to -2, and then from -2 to 4. So that is where it's increased, or no, excuse me, this is where it's linear. It's increasing at A, is decreasing at B. So we're going to look at each of these steps here. And so we're going to look at this holistically, A, B, C, and D, which I wish they would label these different. Let's call this 1, 2, 3, and 4. So it says Robert rides his bike for exercise. Which statement could be modeled? And we're just going to be by each part in the graph. We're going to do 1, 2, 3, 4. So let's just talk about this. We have a distance from home on the y, and this is cut off, but this is time on the x. And so what I want you to know when we're talking about distance versus time, d over time, this is when we look at each of these slopes, we're given the speed. If we have a speed over here in time, our slope is the acceleration. So what we're saying here is this is a speed, this is a speed, this is a speed, and this is a speed. The speed on each segment does not increase or decrease. It is just constant. This slope right here, let's say this slope is 3. It's 3 everywhere on this line. So you're not increasing speed. The speed stays the same from here to here. So just make sure you understand that slope is constant. So you're not going to be increasing speed. So that's a common mistake. Okay, so let's talk about each little section here. Let's talk about what's happening at 1. He starts from home. He ends up somewhere away from home over a period of time. Let's talk about 2. This is straight, constant. This means his speed is 0. He's not moving. The distance from home stays the same over a period of time. He's not moving here. This is flat. He's not moving. In 3, he's going again away from home. Let's look. 1, he was going away from home. 3, he's going away from home. Where is he going faster? Where is the slope faster? It's faster at 1 because this line is more steep. He's still going away from home here, but he's going slower because this is not as steep. And then finally in 4 here, he's returning back home. The distance from home is getting smaller and smaller and smaller. So he's going back home. So let's look. For part A, it says he stopped. Where is he stopped? Well, we said he stopped at 2 because that distance stays the same from here to here over a period of time. He has not moved. So he has stopped. So we're going to look at B and C here in just a minute. Where did he head home? He headed home more slowly than he left. And we can see that this is slower because this line is technically faster. So 4 is where he headed home. So let's look at B and C. He slowly pedaled up the hill at a steady pace, or he rode down a hill quickly. So this is a little confusing because you're like, I don't know. But where was he going more quickly? He's going quickly at 1. So even though this looks steep, like he's going up, he can still be going down a hill away from home. If your house was at the top of a hill and you go down the hill to get away from home, you're going fast down that hill. You're still away from your home, but you're going fast. So your speed is fast. So just because this is going up, that doesn't have anything to do with going uphill or downhill. So this is just you went quickly. Now you're going up a hill slowly, just because you're just going more slowly than you were initially. So don't get confused about going uphill and downhill on what this looks like. This is just the distance from home. You're going away from home. You're going away from home. You're coming back home. And back home could be uphill. And that's maybe why you're even going slow. You could be traveling up a hill slowly to get home. Has nothing to do with this going down. This is just telling us the distance is getting closer to 0. This is telling us the distance is getting away from 0. So those can be a tad bit confusing. So if you want some more practice or have questions, be sure to check your flipped follow-up and help lab sessions on your Class Connect schedule. Thanks.